Hi guys, I hope you're enjoying your snow day. The purpose of this video is to just kind of keep moving forward a little bit with material so that we're not going too long without moving forward and kind of losing our place. So we're just gonna, what I have here is, this is right from your textbook, and I am on where we left off last class about finding the vertex. Let me see, let me just scroll down to what page I'm on, 160. Okay, so you're going to follow along right with your workbook. Some of the examples I'm going to do are meaty examples, so you'll just watch my video instead of the ones in my open math. And at the end of this video, you're going to see what I expect you to do for next class on my last slide here. Okay, so just follow along on your workbook and copy down everything that I'm doing with you. So last class we talked a little bit about, general properties of parabolas and quadratics, and we left off with where we were right here. We were about to talk about how to find the vertex, and you actually did one meaty example, in meaty example 5 for homework, so make sure you have done that before you do this video, because I'm really going to do practice problems from there. So you found out from your meaty example that you did for homework that when you have a quadratic in standard form right here, the form that we looked at last class, so think of your vertex, that's either going to be like the highest or lowest point. So I'm just kind of sketching a parabola right here. Like this one right here would have a low point. That would be my vertex right there. Okay, bear with me with my handwriting in these. So we need to find a way to be able to find that point both by hand, and then we can also look at it using the calculator, but for now we're going to do it by hand in these. Okay, and you also notice that any parabola is symmetric. Okay, so whether it's opening up or down, we have a line of symmetry down the middle of it when it's lined up with the vertex. So that's what they're talking about right here, this axis of symmetry. Okay, so what this gray area in here is saying is that I can find the x part of the vertex. Remember, the vertex is going to have an x and a y. I can find the x part of the vertex with this little formula right here. Okay, that's all I need. If I know b and a from that quadratic, and I do opposite of b over 2a, that gives me my x part of my vertex. And then we know if we have one part of a point and we have a model to plug into, we can plug in to find the other part. Okay, so that's what we're talking about right here, where once I find the x part, let me just find f of that value using my function, and that will get me the rest of my vertex. Okay, so we have a worked example right here. They're showing an example where a, b, and c, a is 1, b is 4, and c is -2. Okay, and they're showing us how to put in opposite of b over 2a. Okay, so opposite of 4 over 2 times 1, so they get an x part of their vertex of -2. So we know our vertex so far is -2 comma something. And to find that rest of the part, our y-coordinate, we find f of -2. We plug it into our function and find the rest of the ordered pair. And then we have our entire vertex, which really gives us a good picture of this parabola. Because now we know we have a vertex, right, oops, sorry about that. Our vertex is right here. And then we can sketch our parabola. Okay, we're going to get better. Right now this is just a sketch, but we are going to, by the end of this, do a detailed graph by hand. And then we have this line of symmetry. I usually do this with a dotted line down the middle. That's my line of symmetry, and it's a vertical line with the equation x equals -2. So that should always match, this part right here should always match the x part of my vertex, because it's a vertical line lined up with my vertex. So let's try to do so my next slide, so this one you completed with your, as part of your homework from Tuesday night, okay, finding the vertex. So I'm going to skip over that one, and I'm going to do the next one right there. Okay, so the you try problem 6. So we have this function right here, f of x equals 2x squared minus 5. So notice there is a term missing. So the first thing I want to do is I want to identify what a is, b is, and c. So a is my leading coefficient. It's the coefficient of my squared term, so that's a 2. Now there is no b term, which means b must have been 0, and c would be a -5. And notice that was also going to be my y-intercept. So when I'm determining the coordinates of my vertex, the first thing I'm going to do is I'm going to define the x. I usually use a little subscript v I do, and other textbooks use that as well, not this one, but I kind of like to distinguish that that's the x part of my vertex, and we find it with negative b over 2a. So that would be, so opposite of b, so it would be opposite of 0 over 2 times 2. So in this case, that's a 0. Okay, so far I know my vertex is 0 comma something. So let's find the rest of it. So now I'm going to find f of 0. So you're going to notice that this happens to be the same thing as my, well, let's see, if I plug in my 0, I end up just getting out 2 times 0 squared minus 5. So I get out a minus 5. So it happens to be that in this case, the y-intercept and the vertex are the same thing. So I'm just going to plot that point. Let's see if I can, it's hard to get it lined up with this. Let's just see if I can zoom in a little bit. Whoops. Here we go. Okay, so 1, 2, 3, 4, so it's right there. If I can get it on the right part. Okay, and my sketch is going to look something like this. It's opening up. Okay. And then they want us to pick out our axis of symmetry. So remember, that's just the line of symmetry going down the center. And the center here has an x of 0. So my axis of symmetry would be the line x equals 0. Okay, it lines up perfectly. These two right here, the x part of my vertex, and this value should always be the same. Okay, so there we have a sketch. It's not a detailed graph, really, because I only have one actual definite point on there. The rest of it's kind of an estimation. Okay, so if you flip over, let's look at problem number 7, determining the domain and range. So the domain, okay, they're giving us a graph right here, and they're asking us, this is a worked example. Okay, just using the graph, we can pick out our domain and range. So the domain of any quadratic, okay, this right here is going to be the same for every quadratic. Okay, because every quadratic is going to be a parabola that goes on and on forever to the left and to the right. Now the range is not going to be the same all the time. This was always going to depend on the vertex. You know, do I have a maximum or do I have a minimum? Does my parabola open up or down? So I have to know my vertex before I can find that. But domain's going to be the same no matter what. So in this case, the vertex was -2, -6. So which means my range is never going to go below -6. Okay, so that's where, remember, we have two different ways we can write it. I kind of prefer the interval notation, say -6 to infinity. Okay, that's because that one had a minimum. If it has a maximum, then it will have a high point that will never go past that high point. So let's try one. Okay, so let's see. We are going to find the domain and range of this function right here, -2x squared minus 6. So before I do any calculations, I am going to have to find the vertex, but I'm going to answer the domain before I even start because I know this is going to be -infinity to infinity. Okay, so my range, I've got to find my vertex first. So we're going to go over and we're going to find what's the x part of our vertex. I think this one is very similar to the one we just did. And so again, on this one, a is -2, b is 0 because there's no middle term, and c is -6. So we get opposite of 0, which we kind of know right there that the x part of our vertex is going to be 0. And the y part of my vertex, if I plug in a 0 in there, I get a -6 out. Okay, so that was just me doing f of 0. That's how I got that. Okay, so there's my vertex. So let's see, this is going to be down here. And this one's going to open down. Okay, so my range on this one is never going to go higher than -6. So my range would be -infinity all the way to -6. And it's going to look that form every time I have a maximum. Okay, let's look at the next page. We'll do one more of this. And then I'm going to show you one example of doing a graph completely without the calculator at all. Okay. So this one we're going to do, again, domain, range, and vertex. So again, I'm going to fill out this part before I even start because I know my domain is all real numbers. So let's go over on the side and find our vertex. This one is very similar. Okay, this one happens to be, again, where A is 2. I think this is one that was on the other example as well. B is 0, C is it is, right? So opposite of 0, so we know this one is coming out to be the X part of my vertex is 0. Let's find the Y part of my vertex. We already found that in a couple examples ago. If I plug in 0 for X, good practice though, I get out a -5. So this one had my vertex at -5, and it opens up because it's a positive A being positive makes it open up. So my range, that's kind of not a great graph, but that was supposed to be my lowest point. My vertex was right there. Okay. And so my range on this one, my vertex on this one is a minimum. So the minimum it's going to be, it's never going to go below -5. So all my Y values, remember Y is up and down, are from -5 to infinity. So that would be my range for that one. So the next thing we're going to do in class is to find the horizontal intercepts using the calculator. Okay. Then in a couple days after that, we'll go through all the ways to find the horizontal intercepts by hand. I'm not going to have you do the meaty example on this next part right here, because I kind of think there's an easier way on the calculator to show you. You might be able to do both and kind of decide which one you like better, but I would like to do that one in class so we can at least go through both methods. So what I would like to do next, and this you'll have to take out a piece of paper, and you're going to keep it in your binder. I would like to do one from start to finish by hand, okay, and show you how to find some other points if I really want to graph something by hand without the calculator. So I have this quadratic written out, so make sure you get another piece of paper, or if you have a blank sheet in your workbook or a blank spot, you can do it, but you want a nice bit of space. We're going to graph this one by hand. So the first thing we're going to do is we are going to find the vertex using everything we just did. Okay, so my X part of my vertex is going to be, so let's list A, B, and C. A would be, if it's X squared over 2, my A is going to be 1/2. Okay, because there's really a 1 in front of that X squared, and we can't forget about that 2. B is going to be 4, and C is -1. Okay, so the X part of my vertex is -4 over 2 times 1/2. Okay, well 2 times 1/2 is just 1. So I really have -4. Okay, so there's part of my vertex. I know my vertex is -4 something. So let's find the Y part of my vertex, which means I'm going to plug in f of -4. And let's see what I get out. So it's going to be -4 squared over 2 plus 4 times -4 minus 1. So let's see what that comes out to be. We would have, I'm just going to come over here. I'm going to save this spot on the right for my graph. We have 16 over 2 minus 16 minus 1. So we really have 8 minus 16 minus 1. So we end up getting -8, so we have -9, okay, is the rest of my vertex. Okay, so let's see what we've got here. Let me kind of make a little bit more room if I can. Okay, so let's plot what we've got so far, okay? So we've got, let's do this the best we can. I'm going to extend this a little bit further down. Okay, so let's see. This the best would be on graph paper, but I didn't have a graph to input into this. Let's see if we go down for enough. Okay, so my vertex is 1, 2, 3, -4, -9. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's down here. This is definitely not the most perfect graph, okay? But we have a line of symmetry down here that's lined up with my vertex. Okay, so what I want to do next is I want you to find another point on the graph. Okay, the easiest point would be find that y-intercept. Okay, which we learned in class the other day that the y-intercept is C. So my y-intercept would be the point 0, -1. Okay, so let me plot that. So 0, -1 would be right here. Okay, that gives me another point to connect. And if I just have one more, then I'm able to connect this whole parabola and have a nice detailed graph. So I want you to think of this line of symmetry, and remember this whole thing will be symmetric. So if the vertex is over here at -4, if 4 away, 1, 2, 3, 4 away, it's down at -1. That means 4 away this way, 1, 2, 3, 4, it's also going to be down at -1 because this would be a mirror image of that point. And once I do that, I can connect my parabola and get a nice detailed graph. That's no longer a sketch, that's an actual graph. So I did that by finding another point, which was my y-intercept is always an easy point to find. And then I did a mirror image of that y-intercept, was just figuring out how far away from the vertex was I, and then I went the other direction. And that gave me a third point that I could connect. Okay, so we're definitely going to do another one of those in class, but I am going to have you try one of those by hand at home as well this weekend, and I'd like you to use this as a model. So this last slide is your homework, okay? So the things that I want you to do for Tuesday's class are, if you go on to page 282, actually that might be 182, let me just make sure that that's the right page. It's in practice problems. Yeah, that's actually supposed to be 182. It's right, continuing where you were last time. You did number 1 the other day, so you're doing number 2, only one problem. Okay, just practice find the vertex. Then I want you to take this one function that I gave you right here and try to graph it by hand. If you have graph paper, that would be perfect to do it on that. Okay, and keep in your notebook. It's going to be part of your binder check and part of what I check on Tuesday. And then you've got to complete your mini project, which is on linear regression. Okay, not on quadratic stuff. It's on linear regression. Okay, and that's due on Tuesday. And remember, we moved your test to next Thursday, so we'll have class on Tuesday to be able to talk about that. Okay, so if you've got any questions, feel free to email me in Blackboard. If you need to watch this video again and use it as a model to do this homework, please do so. And then just, again, let me know if you have any questions. Okay, enjoy your day. Bye.